Audible and visible.
Yes, sir. Yes, sir. You're audible, sir. Slides are visible. Over to you, sir.
Okay. Thank you very much for this invitation and this opportunity to discuss further the issues raised today morning for Athens, but afternoon for India and maybe many other countries in the world that participate in this beautiful discussion. So my talk today is further to the previous speeches about the multidisciplinary delineations of the framework for responsible and ethical AI in society transformation. I want to be a bit more detailed than the previous speakers. So I will with an outline. I will focus on the fourth subject, which is the framework for ethical and responsible AI, principles and details, with some new material. This is based on my two recent publications, one in journal, one in a Springer conference. So the issue of responsible and ethical AI, as we already discussed Horizon conference, is very critical to control AI. This is actually the principle of all discussions so far. The major issue that I will try to outline is that any framework without the involvement and the engagement of humans is impossible. If we let the things to companies, to big enterprises, the things will become strange and dangerous. I will come to this nearly the end of my talk. So the principles here are that we are in an era where we have huge data processing, big data analytics and data processing that can be done only, of course, through AI and data science. The second thing is to analyze a bit about the responsibility, to show you some of the challenges regarding a framework for controlling AI, and then I will come to the principles of such a framework. So we all know what is artificial intelligence, so I will emphasize only one thing because the rest is known. When we talk about AI, we talk about narrow AI. It's AI that can solve specific tasks. We are, however, also in the era where AI can build and can control autonomous systems. It's something more than the narrow intelligence, is something like broad intelligence, but it's not general intelligence. They claim we are near general intelligence, but of course we are not near. What we have seen up to now, and we will see together, but in a hurry, these issues, what we know is that with the advent of generative AI, we are in the possibility to produce reasoning, to produce machines that can reason or seem to reason. This is the generative AI and goes well, but with many, many errors, many hallucinations, etc. I will not stay with the historical background, but I will stay with the current advancements in order to discuss how to control things. Of course, when we say AI and society, because this is the theme of the conference, is the integration of AI in several sectors, including, of course, public and private. E-governance, for instance, in all countries now, either in tax organizations or in the state, let's say, policies towards the public. We know very well that the state has many applications now, in all countries, in order to facilitate services, state services to the public. And also private, because not the majority yet, but a big percentage of companies already started to use AI and generative AI. So integration of AI is in progress. Not yet in very big progress, because we understand the limitations and the companies understand the limitations. But I can tell you that programmers, for instance, it's only for instance, for programmers, novice programmers, with only 1 year or 2 years of expertise can be replaced by generative AI, and therefore, of course, the supervision is done by senior programmers, but the AI code is good, not very good, but good, can replace novice programmers, and it's fast, of course, 1,000 times faster than a novice programmer. So you understand that the companies require such fast and with a few or bigger mistakes by AI, instead of having and paying programmers, novice programmers. Another thing is the emerging societal shifts due to AI adoption. We heard from the previous speakers some issues, but I want to emphasize here, although I will not be very detailed in these shifts, since my issue is how to control, what is needed to control AI. But in any case, we see a shift, for instance, of health services. Health services might be facilitated a lot with AI adoption, not only electronic health record, but even telesurgeries we can have through robots. And fourth industrial revolution, we can have even surgeries remotely. This is done by AI, but all decision making now, at least in middle level, can be done through AI. And this is big. This means that intelligent machines, intelligent systems in general, are with us. And we live together with these intelligent machines in whatever level they exist now. And we should understand also that we are only in the beginning. Take this into account. We are in the beginning. After 70 years of research starting from 1956, now we are in the beginning of real AI, real world AI. Another big shift is in, for instance, in legal science, in law science. We see fast adoption of AI in order to make justice fast, with a lot of risks, of course. So there are several sectors that now are shifting through AI adoption. But about data, All this comes because of processing huge amount of data. And data is the new oil, as I mentioned here. Millions and billions of records of data and trillions soon. And why is the new oil? Because this data is building the training sets of generative AI. This is the reason. So the global truth lies on all this data available in the internet, in libraries. The internet now is the human library, covering everything, as you know very well. And therefore, we can say that reliable data is true new oil. Of course, nowadays, generative AI uses all data without weighting their reliability. This is bad. You can see in the answers of generative AI, either in Google or in Copilot or in other tools, you can see very well that not all sources of AI answers are trusted. They convey everything, even bullshit. No one controls this bullshit. Of course, it's controversial. You understand this? It's controversial. If we say, no, we will use only high quality data, what is high quality data? Are we agreeing all in the quality? Are we agreeing all? It's not so clear. So companies should use all data as a democratic, let's say, attitude. However, this is not fully correct. We need mechanisms to control facts, histories, stories, and data. Facebook, for instance, has such a service controlling the news. And if something is false, is identified as false, they hide this. But are we sure that the ones that decide about positivity, these are the truth? These are the true ones. These know the truth. Is Facebook correct? No. To my side, it's not correct. Because in order to discuss if something is false or not, there is no one company per country to decide what is false and not. There should be open discussion between several parties, including the ones who used these facts. Otherwise, the facts, we don't know if they are false or if we live in a period of non-democracy, because this is the major issue. If we say this is false, without proofs, without discussion, then we are not living in a democratic state, in a democratic society. So we understand the dangers. On the one side, we have bullshit and true data in trillions of records. And on the other side, we have claims from Facebook and others that they try to control, but maybe they want to try to control democracy and not falsification and truth. So about the data, one only comment. In 2020, the data all over the internet per day, okay, per day, there were 44 zettabytes per day. Be careful. As an average, this is really huge, very huge. As I promised, in very short, about the history, you can see an outline of the history. What I want to emphasize here is we start from of course, 1940s, and 1956 is the first big plan for AI in Dartmouth College in USA by McCarthy, John McCarthy, not the other McCarthy of, you know, the other McCarthy in politics. So we have the implementation, starting of implementation of Turing machines during the 50s. During this period, we have perceptron underline the very initial neural networks. After that, in the 80s, after a dark period of nearly 20 years with no research, and the only research was expert systems, we have the backpropagation algorithm as the workhorse, and then end of 80s, the support vector machine, and many, many other beautiful algorithms for small neural network architectures. And then we go to end of 90s, 1997, 80s, etc., with LSTM deep learning. We have CNNs, deep convolutional learning, deep Boltzmann machines during the initial 2000, and then, of course, GANs during 2012 or something. But after 2015, we have built the real armament of deep learning, and now, together with GPUs, the hardware, we have the capability to process data at large, the zettabytes of data. We know the breakthroughs. 1997, the Deep Blue platform challenged and won Garry Kasparov in chess. 2016, Google's AlphaGo beat all world champions. 2023, we have, of course, the ChatGPT advent. And 2020, DeepMind from Google was challenged. Actually, the experts in screening breast cancer were challenged too heavily. Actually, they were defeated by the DeepMind of Google. So we have clear evidence that even from 2016, we can say 2015, we have clear evidence that AI is becoming very powerful and can challenge human experts, not us, not simply us. So, together with such power comes responsibility. And what is responsibility? This is an issue. Responsibility means several things that we will see. 5 pillars, as I call. The most important issue is to explain AI models and understand their decisions. So the big issue here is that up to nowadays, even with deep learning, our models, AI models, use optimization techniques. For instance, Adam optimizer in the deep learning machines, backpropagation in the initial small with 3-4 layer multi-layer perceptrons. So optimization of an objective function is the true, let's say, methodology that, deals with real-world problems and leads to very good results, But through optimization, we cannot understand the process. Optimization is a highly iterative algorithm, and we cannot track what happens. So the process is implicit. The rules are implicit and very difficult to understand. You can see in the small networks we had only to draw boundaries between classes. Here with deep learning, we have huge machines with billions of parameters that is very, very difficult to understand what happens there. I will be fast in these things in order to go to what any kind of framework should have in order to be characterized as responsible and ethical AI framework. So accountability is, you can see here in the graph also, accountability is the important thing for the first important thing for responsible AI, which means all facts should be logged in files or in whatever. Of course, in files, when you try to log and register facts, billions of facts, how to deal with them? You need another AI model to deal with this accountability. Interpretability. For small models might be possible, but for big models, it's very difficult, as we will see in Harry again. Fairness, no bias. Safety and privacy, we understand very well. We need our systems, intelligent systems, to be safe in use, for instance, in autonomous cars. We don't want to harm anyone with our systems. So safety is a must. Privacy, since all data from Google or from the internet, basically, contain even private data. Also the national health care systems, NHS, for instance, in UK, or the relevant NHS everywhere. They have private data. Through attacks, such data may be revealed. We read in the newspapers, in the news, we read about such private data revelation. So our systems should have these clear 5 pillars. But interpretability is the most important issue. Why interpretability is the most important issue? Because humans cannot trust any kind of machine without understanding it. The machines now, or up to now, I don't know in the near future, there are some methodologies I will present in Harry, but the machines up to now are not anything else but black boxes. Of course, any one of you could tell me that why human brain is also a black box. Do we understand how the brain works? No, we don't understand. Of course, we don't understand. But we trust the brain because humanity trusts the human brain because society is based on human decisions, etc. And we see that in the majority of cases, we have good progress and reasonable decisions. So we trust. But can we trust a machine that we do not understand what happens there? So humans cannot accept at large machines that are not interpretable. But nowadays, you can see also in Grok, even in ChatGPT, in the new ChatGPT, you see some effort from the developers and the designers to describe a bit the reasoning. Grok started with explain XAI, explainable AI. So we understand that explainable AI is the new must now. Why things are so difficult in order to interpret? In a hurry again. Xi is based on three major models: pre-model, in-model, and post-model interpretability and explainability. Pre-model means to understand the data. This can be done through clustering, for instance, K means K nearest neighbor, etc., etc. So we try to understand the probability distributions of data. In model, we try to understand the AI model layer by layer, actually. The neurons, what are they doing? Actually, we are not going to neuron level, but to hidden pattern level. So in model is seek patterns in the big models. And post-model is to compare decisions and patterns produced by big deep learning with patterns, existing patterns, training patterns, prototypes. So there are many methods for post-model. You can see gradient, decomposition, optimization, deconvolution, etc. I will not stay with the details. Decomposition means to analyze layer by layer. Nearly all these methods, gradients is about understanding the changes, the differences. Deconvolution is about to understand sources, different sources for the decisions. Optimization, of course, is how to find the real important patterns that these optimize the decision. So we have methodologies. I have outlined here a table with all these methodologies for certain initial images. So you see initial images and you see what the methodologies understand. You can see even, for instance, deep Taylor means, as you understand, Taylor series in mathematics is to understand the changes through first order derivative, second, third, etc. So you see some resemblance with original image, but of course, from this, you cannot understand very well. You need an AI model in order again to interpret, but you see the patterns produced by the post model. So having such patterns, we cannot associate. Is this associated with this? Yes, because this is derived from this. But is this associated, for instance, with this? No, the differences are large. So we can understand from such patterns, we can understand original patterns from training set that can lead to decisions, because this is an inherent pattern of the deep learning involved in analyzing this image. So we try, instead of not trying to identify and compare this image with this image, we compare such patterns. It's much easier to understand the differences. You can see this and this, much difference. This and this, many, many differences. It's easier to compare such derived post-model patterns than trying to analyze and comparing original images. Much, much easier. I will go further. The black box issue makes our life very difficult on how to control bugs, how to debug our models. It's not impossible, but it's very, very difficult. We have methodologies. Don't believe that there is no methodology, but these still are not very efficient. So Compass and CoreLs are two methodologies. I don't have time to be analytic in this. The important question is, are these models that we train in generative AI and other AI models, are these models extracting meaningful features? Can we build a transparent and, let's say, interpretable outcome? This is the big question. So we have, for instance, such an image, and what we are doing in image processing with deep learning is to take, of course, sliding windows. You can see the sliding windows, you can see, and we analyze these sliding windows, and we try through such small images to further. This should be connected with prototypes. For instance, here you see in a complex background a bird. If we put this as a whole to the network what is doing is to analyze in patterns, in specific sliding windows, in order to find out special, let's say, patterns that match. For instance, this could match. This looks like this pattern. This might looks like this. So you understand that what happens with AI, what is this? Is to associate sliding windows in images or text in natural language processing with known patterns. Your query in generative AI is a complex pattern, let's say. The model analyzes this in phrases and tries to associate, to correlate with existing text in the library of the model. The same with images, with signals, with everything. Actually, our intelligent machines are seeking patterns, similar patterns. This is the big thinking behind intelligent machines, is a way to analyze patterns, patterns matching, complex pattern matching, however. You can see here the model, CNN models. This is a CNN model, and with the, you can see the layers, max pool here, and dropout, etc., the fully connected layer who takes the decision, etc. So such a model you should have in mind, a very complex model with billions of parameters, that we should introduce here some kind of interpretability. And by interpretability this is the concept for an interpretable and explainable AI, together with a decision, instead of saying this is a bird, okay, to output the model, to output all relevant patterns that the model has been based on in this decision. How this is done? Because each layer produces patterns. So we take these patterns and we see what happens if there is any possibility to be so, because the relevant patterns come from birds. This is the reason he decides bird. This is the models in order to have an accounting of what happens. And I go to the last part of 10 minutes with the framework. As you understand, the pillars are 5. We should discuss, and we will discuss shortly, We have discussed up to now the overview of responsible and ethical AI, the challenges. We have discussed also the challenges. And now we know also, we have discussed a bit, but we'll discuss in 2 minutes something more about how AI can shape societal transformation and the importance of ethics. So the core principles are transparency, fairness, accountability, and privacy. We understand that if there is transparency and accountability, safety with extensive tests could be a bit, let's say, not a problem. But in any case, the pillars are 5, not these only 4. We heard also from the previous speakers, we should develop AI that is aligned with human values. We should have extensive risk assessment and mitigation strategies. And the most important thing, stakeholder involvement. I will talk but briefly about this. So what are the transformations, first of all, in order to discuss the framework? Boosting economic productivity and efficiency. We understand this. We have also predictive analytics for companies, for stock market, for whatever. To improve healthcare, as I told you already, education, public services. To enhance sustainability and environmental protection, because don't forget, we live in a world now with few sensor networks, but cameras are everywhere. And sensor networks soon will be everywhere for environmental and not only for criminality. We understand now that what happens with cameras is to identify crimes, not for other issues. But now we have the environmental problems, and therefore we need environmental protection through analyzing the sensor networking data. This is big. Growth opportunities are based on all this. The challenges already we talked about, bias and discrimination in training data. So we need clear training data, and this is the most difficult problem. Lack of diversity in AI development teams. We have monolithic minds in every company. We don't have discussion between stakeholders, companies. The system should be open and should be opened now because this lack of diversity produces a lot of risks. Opacity in algorithmic decision. This is the black box problem that I told you about in detail, and this is very critical. The addressing of bias can be done. So the important thing here is to have data sets with fairness and inclusivity. This is very important. To develop also AI tools for representing other representing groups. So you understand, in order to address bias and fairness, we need to rebuild our data sets through very careful AI engineering in order for all minorities to be inclusive. Also, we need to develop XI models, explainable AI models. We need traceability and auditability from experts and from the society also. So we need engaged society. Openness and documentation. Open source AI development, now DeepSeek and other Chinese models are open source, and communities should be able to validate. transparent data collection, and community involvement and engagement. Consistent communication between all partners. This is very important. Only communities can control companies and can open the systems. Otherwise, we cannot control. We cannot build these models of explainable and fair AI. And we have regulatory frameworks, but unfortunately, these regulatory frameworks are insufficient. We have the EU AI Act, which is unfortunately very restrictive and hinders innovation. We have the USA regulatory framework, which is only ethical framework, nothing else, doesn't legalize anything. So we need to build something between. The engagement, as I told you, for instance, some in very hurry because my time in 5 minutes is over. Case studies is for ethical AI practice. As I told this, with AI predictive healthcare, but saving private data, ethical challenges in facial recognition. You understand this issue. They take our data, but privacy. Best practices for tech companies in order to control tech companies. And lessons, of course. You can see here my final, the previous to final, let's say, slide. You can see the responsible and ethical AI parts. Is the prospects that we have discussed. We can do a lot. We should address bias and fairness. We should ensure transparent and explainable AI systems. We should build ethical framework. We should build these frameworks through several test cases and audits. We should address transparency and, of course, the regulatory framework. And I come with a final transparency, which is a use case diagram for such a framework. We should involve the developers, companies, the regulators, not only the governments, societies, IEEE, and other societies, and users, the communities, should interact with AI systems and provide feedback. Auditors should be frequent working committees in order to audit fairness, safety, transparency, and so on. And community stakeholders. The community stakeholders, the big, and not only the big stakeholders, should curate the data sets, should every time check data sets. The companies should not be allowed to use whatever they want. It's the society that should guide what is real, what is false, what is fair. So you understand this is a very big discussion. How to do inclusive data sets, how to curate such data sets. You can see also the use cases to implement the developer, to monitor the compliance, to have access and feedback the end user, to conduct audits, provide feedback, update the frameworks. I don't have time for other things, but only for a final conclusive slide. The proposed framework is based on IEEE P6000 and also is based on explainable framework like SAP and AI fairness framework, but involves, as I told you, full community engagement. Without this, nothing can be done. The other relevant frameworks, AI for People, launched in 2018, and OECD AI 2019, agreed by 42 countries. These are relevant frameworks, but the problem with these frameworks is in major, they are ethical frameworks. And as EU Act is not only ethical, it's legal, legalizes and penalizes everything. We cannot have innovation with such legalization. We need more, more autonomy and control together. This is the principle of the framework I presented in my publications. There is a lot of work to be done. Unfortunately, the issue is very complex. We live in an AI era that the intelligent machines introduce more problems, maybe, than what they solve. I will conclude with an example. MIT made a very recent research about ChatGPT impact on brain for students. So ChatGPT and no ChatGPT. In the ChatGPT problem solution, in the non-ChatGPT, the brain is working fully. In the ChatGPT problem solution based, the student brain doesn't work, works only a very minor place in the brain, nothing. You understand the big problem now is not only fairness, explainability, decision-making, is that we may lose critical thinking. We may lose even thinking because we trust everything ChatGPT says. So thank you very much for your attention. I hope with these recommendations, if we take seriously, these all are in my publications, as I told you. And here is a presentation of the main points because I don't have any more time. Thank you very much for your attention.